Hello friends, welcome to our channel Knowledge Amplifier. So in my previous video, I have shown you the intuition of support vector machine, and along with that I have discussed how you can implement support vector machine in MATLAB. Okay. So now what I am going to discuss, that is mathematics which works behind this particular algorithm. Okay. Some part I am going to discuss in my this video, rest part I will discuss in my upcoming videos. Okay. So let's start the discussion. So I hope you all have studied straight line concept in your class 11 mathematics course. Okay. So here in two-dimensional plane, I have drawn one straight line. Okay. Which popularly, the popular equation for straight line, as you know, y equal to mx plus c, where m is the slope and c is the intercept. Okay. Now, what we do in most of the machine learning computation for the equation of hyperplane, okay, we convert this to matrix form. Okay, and let's discuss first the matrix form of this particular straight line, okay, equation. So y equal to mx plus c, so you take all the terms in the left hand side and you will be getting y minus mx minus c equal to 0. Okay, now take all the coefficient of x and y and put in a single matrix. What you will be getting, let's define the matrix as omega, okay, which is equal to, first write the coefficient of x, which is minus m, and coefficient of y is 1. Okay, so you will be getting this matrix, and another matrix I am creating which is x, which is having x and y value. Okay, now you just calculate omega transpose x. Okay, omega transpose means this column vector or column matrix will be converted to row matrix, right, or row vector. So you will be having, if you take transpose of this minus m1, you will be getting like this, and we are multiplying this x matrix, which is basically xy, like this. So if you just simply do matrix multiplication, you will be getting minus m into x plus 1 into y. So omega transpose x is nothing but minus of mx plus y, or we can say y minus mx, which is basically this particular part. Okay, so now just what you do, you subtract c from both the side. So what we have got, omega transpose x equal to minus of mx plus y. So now if you subtract c in both the side, you will be getting omega transpose x minus c equal to minus of mx plus y minus c. Now minus c, you can consider it as one more constant b, where b equal to minus c, and as a result you can rewrite the equation like this: omega transpose x plus b equal to y minus mx plus b, which is nothing but y minus mx minus c, we can say, right? So what we have got, we have got the matrix representation of our straight line, where we started with y equal to mx plus c, then we have taken all the terms in the left hand side, and y minus mx plus b equal to 0, we can say. Okay, because y minus mx minus c equal to 0, if you replace minus c with b, you will be getting this equation: y minus mx plus b equal to 0, and y minus mx plus b is nothing but omega transpose x plus b, so we can say omega transpose x plus b equal to 0. And here transpose notation, if you don't want to write like this, you can write like t. So this is our equation for straight line: omega transpose x plus b equal to 0. Okay, general equation, where omega is nothing but this minus m and 1, and x is nothing but xy, one particular point in our two-dimensional plane. Okay, now you can extend the equation to 3 dimension, 4 dimension, does not matter. Okay, so now let us try to understand how the equation will change the sign, or what value it will take if we take some point above this particular line and below this particular line and some point on the line. Okay, so let us consider the simplest case first, where point is placed on this particular line. Okay, so case 1, suppose I am taking one point x1 y1 which is placed on this particular line. Okay, so as this particular point x1 y1 is placed on the line, so it will satisfy the equation of the line. So if the equation of the line is y equal to mx plus c, so y1 equal to mx1 plus c will satisfy. And again you can do that kind of same mathematical computation as I have shown. Take all the terms in the left hand side: y1 minus of mx1 minus c equal to 0, replace minus c with b, and y1 minus mx1 we can write like this: omega transpose x, where in this particular case omega is same, minus m and 1. Okay, but x is nothing but x1 y1, that is X is basically matrix for this particular data point x1, y1. So what we are getting, omega transpose X plus B, this particular set will take 0 value if X, that is this particular point x1, y1 is placed on the particular line. Okay, so omega transpose X plus B equal to 0 if we take some X value, that is x1, y1 point which is placed on the line. Okay, case 2. Consider a point which is placed above the line, like here x1, y1. Now what you do, you just take projection of this particular line on of this particular point on this line, and you will be getting same x coordinate x1, but y value will change. Suppose let us consider y0. Okay, so this x1, y1 is basically representing any point which is placed above this particular line. Okay, so if you consider any point above this particular line, obviously one thing is going to happen, y1 minus y0 will be greater than 0. Right? This particular equation I hope you can understand simply from this particular graph itself. Now what is y0? Y0 is nothing but this particular line equation. If you consider y equal to mx plus c and x1 y0 is placed on this particular line, so we can say y0 equal to mx1 plus c. So replace that and you will be getting y1 minus of mx1 plus c greater than 0. Remove the bracket, you will be getting y1 minus of mx1 minus c greater than 0. Replace minus c with b, you will be getting y1 minus mx1 plus b greater than 0. Right? Then similarly apply the same concept. Okay, so y1 minus mx1 we can write like this, minus of m1 and one matrix x1 y1. If you just do matrix multiplication, minus of mx1 plus y1 you will be getting, which is nothing but this particular term. Right? So we can rewrite like this, plus b greater than 0. Now what is this one, minus of m1? That is nothing but omega transpose. Okay, right, because omega equal to minus m1 column matrix, and this x is nothing but x1 y1. Okay, that is x value for this particular data point. Okay, so what we are getting, if you just replace, you will be getting omega transpose X plus b greater than 0. So what we are concluding, any point placed above this particular line will satisfy this particular equation. That is, if you put that x1 y1 value in this particular equation, omega transpose X plus b, you will be getting any value greater than 0. That may be 10, that may be 100, that may be 2000, but the value will be greater than 0. Sign will be positive. That's what I want to say. Now the third case, consider any point which is placed below this particular line. Okay, like here we are considering x1 y1 point, any arbitrary point placed below this particular straight line, and again if you take projection on this particular line, x value will be same, y value will change, you will be getting x1 y0. Okay, and here you can say that y1 minus y0 will be less than 0 for any point which is placed below this line. Right? So as x1 y0 is placed on this particular line, so it will satisfy the equation. So we can say y0 equal to mx1 plus c, and this is also obvious that y1 minus y0 will be less than 0, as this particular point we are taking below this particular line. Now substitute y0, you will be getting y1 minus of mx1 plus c less than 0. Just remove the bracket, you will be getting y1 minus of mx1 minus c less than 0, and again y1 minus mx1 you can rewrite like this particular matrix form, minus c less than 0, replace minus c with b, and replace this one with omega transpose, replace this one with x, you will be getting omega transpose X plus b less than 0. Okay, so what we are concluding, that if we are taking any point on this particular line, and if you substitute in omega transpose X plus b, where x equal to that particular point x1 y1 data point, then you will be getting equal to 0 if that particular point is lying on this particular line. If you are considering any point above the line, you will be getting positive value, and for any line, any point below the line, you will be getting negative value. Okay, that may be minus 1000, that may be minus 2000. I am not going to magnitude part, I am just telling that the value will be less than, sign part, okay, will be negative for any point below this particular line. So this is the conclusion of three cases. Case 1, omega transpose X plus b equal to 0 when x1 y1 on the line. Omega transpose X plus b greater than 0 when x1 y1 above the line. Omega transpose X plus b less than 0 when x1 y1 below the line. Okay, so for classification, okay, for SVM classifier, whatever we have seen till now, our actual point of view will be based on sign. Okay, not magnitude. That is, sign of omega transpose X plus b is what we need. Okay, how you might ask? See, if you consider any data point in this particular region which is below this particular line, it will be having negative sign. So we will consider if any new data point come, what we do, we'll just put in the omega transpose x plus b if we know the omega value and b value, okay, and we will check whether sign is negative or not. If the sign is negative, we will say, if we are getting a value lesser than 0, we will say that that particular point will belonging to this particular negative class or this side, okay. And if a new point come and after substituting to omega transpose x plus b we are getting some value greater than 0, we will conclude that that particular point is belonging to this particular region. So these two classes, this particular line is forming. This is positive class, this is negative class, right? So this is what I want to say. Although we are not considering the magnitude part, but here comes the concept of magnitude, okay? So what I want to say, that suppose you are getting for any point which is situated, any new point after substitution into the equation omega transpose x plus b, you are getting negative value, suppose. And suppose for one point you are getting minus 1000, for one another point you are getting minus of 0.1, then you can surely say that newly coming point for which you are getting value minus 1000 is belonging to negative class, because that is highly negative. But if for one particular point you are getting very small negative value like minus of 0.01, then the confidence in saying that that particular point is belonging to negative class will be not as much high as earlier, okay. So if the magnitude in the negative of positive or in positive direction is high, then our confidence in the classification will be more. So obviously, although we are not that much bothered with the magnitude part, but if we are considering magnitude part, obviously our confidence in the classification will be more. That also we can see, right? So this is what we have concluded, that for this particular line we have visualized for any point in this particular region will be positively classified, and for any point in this region will be negatively classified, okay. So our binary classification objective is done, and the motivation is all the positive points should be as far as possible and all the negative points should be as far as possible from this particular line. That is, all the positive points should be as high value as possible and all the negative points should also have as high negative value as possible, and that time we will be having high confidence about our prediction, okay. As I have told you, that minus 1000 if you are getting for some point, then you will surely say that that is negatively classified, that class is belonging to negative class. But if you are getting minus of 0.01, then the confidence level will be little bit decreased, right? Because this is kind of optimization problem. So optimization sometimes lead to misclassification. If the result is very small, then there will be less confidence, and if the result is high, then misclassification probability will also reduce, okay. So our actual aim will be magnitude of omega transpose x should be as high as possible. That does not matter in negative or positive. If it is high value in negative direction, we will conclude that point belonging to negative class with high confidence. If this particular value is taking very high value in positive side, then we can say that that particular point is belonging to positive class with high confidence. But the aim, in simple, we can generalize that mod of omega transpose b, there is absolute part, should be as high as possible, okay. So this is what about this particular video. I hope you have understood this particular 3 cases, which is very, very important: above the line positive, below the line negative, on the line 0, okay. So this is what about my today's discussion. I will discuss the optimization function and some more mathematical concept related to SVM algorithm in my upcoming videos. Thank you for watching.